So in this example, we have two competing conjectures that actually go back to an example we looked at in section 1.1. Stefan says the difference between consecutive perfect squares is always odd, and Francesca says the difference between consecutive perfect squares is always prime. So we actually gathered some evidence on this in section 1.1, and we found the difference between consecutive perfect squares. So we did 4 minus 1, and we got 3. We did 9 minus 4, and we got 5. We did 16 minus 9, and we got 7. At this point, both of these conjectures are in fact true. Stefan saying that they will always be odd is true. Francesca saying they'll always be prime, and again, prime numbers are any number that's only divisible by 1 and itself, so 2, 3, 5, 7, 11, 13, 17, and so on. And as I said in section 1.1, 3 pieces of evidence is enough to make a conjecture. But 3 pieces of evidence is not always enough to determine whether the conjecture is true. It may be the 4th or 5th or 100th piece of evidence that shows that it's false. So if we keep going and gather more evidence, our next 2 perfect squares would be 25 minus 16, which would give us 9. This is enough to prove that Francesca's conjecture is in fact false, because 9 is not prime. So Francesca's conjecture is false, but Stefan's is still true. And in fact, no matter what, if we kept going and gathered more evidence, Stefan's conjecture would in fact continue to be true. All it takes is this one piece of evidence to show that Francesca's is false, though.